Hello friends, welcome back to my channel Maths by Samit Deshmukh. So in this video we are solving word problems from Miscellaneous Exercise 2B of Matrices. So if you are new on my channel, subscribe the channel and hit the bell icon so that you will get notification of every newly uploaded videos. So in case of word problem, first we have to read the condition in the example very carefully. Using condition, first we have to form the equation. So let us see what are the condition in this example. The three numbers, the sum of three number is 6, and what is the question? Find these three number using matrices. So sum of three number is 6. So let us denote these three number by what? X, Y and Z. And question is to find out three numbers, means question is to find out value of X, Y and Z here, because required three number we are denoting by what? X, Y and Z. So let us use the condition to form the equation. What is the first condition? Sum of three numbers. The numbers we have denoted by what? X, Y, Z, and sum of these three number is 6. So according to given condition, let us see what we will get. According to given conditions, we get. So first condition says that sum of these three numbers will be equal to 6. So in this way here we have got equation number first. Observe the second condition. So in the second condition, if we multiply third number by 3, third number means what? Z. So if we will multiply third number by 3 and add to the second number, which is the second number here, Y, and add to the second number, we will get what? 11. We will get 11. So which implies that, so here 3Z plus Y can be written as Y plus 3Z. On this side 11, keep it as it is. So in this way we have got equation number 2. Now observe the last condition. By adding first and third, we get a number which is doubles the second. By adding first and third means what? X plus Z. By adding first and third, we get a new number which is what? Double the second number. Second number is Y. Double the second number means 2Y. Let us write down this equation as X plus 2Y. On this side will become minus 2Y plus Z, keep it as it is. On this side remaining term will be 0, so denoted by equation number 3, just using transformation. Plus 2y on this side will become minus 2y. In this way we have got three equations. Once the equations are known to us, first convert this equation into matrix form. So therefore matrix form of the equations. So whenever we are writing the equation in the matrix form, in first matrix we are collecting coefficients of what? X, Y and Z. So observe, in the first equation what are the coefficient? 1, 1, 1. In the second equation, term of X is absent, means its coefficient is 0, coefficient of Y is 1, Z is 3. And in the last equation coefficients are 1, minus 2, 1. And on this, in the second matrix we are collecting the variable, and on this side we are writing constant term, that is 6, 11 and 0. 6, 11 and 0. Simply first, second and third equation we have converted it into matrix form. Now we have two choices. Either solve these two equation applying reduction method or inversion method. But we have already observed that reduction method is easy comparatively to what? Inversion method. Inversion method is also easy, but very long method is there. So that's why I'm giving priority here to solve this equation applying reduction method. So to convert or to solve this equation applying reduction method, we have to convert this matrix into upper triangular matrix. Means these two elements, if we are able to convert it into 0, already here 0 is there. If these two elements we are able to convert it into 0, matrix will become upper triangular. So to convert this element into 0, operation is on R3. What operation we have to perform? R3 minus R1. So that 1 minus 1 will become 0. So let us perform this operation on the element of R3. So that's why keep the element of R1 and R2 on both sides as it is. What is the element of R1 here? 6 and here 11. On this side 1, 1, 1, 0, 1, 3. Keep it as it is. So operation is on R3. 1 minus 1 will become 0. Minus 2 minus 1 will become minus 3. And here also 1 minus 1 will become 0. And on this side 0 minus 6 will become minus 6. Now here these two elements become 0. It is sufficient to solve these equations Now better way, take the multiplication of these two matrices. Easily we are able to convert this element into 0 also, but if you are simplifying here, adjacent, if you are simplifying till we will get the value of z here, and once the value of not z, y we will get if we are adjacent, if we are taking the multiplication. So take the multiplication of these two matrices. Hope you have got it. This matrix is not becomes upper triangular, but here these two element become 0. So at least two element of the third row become 0. We are able to apply reduction method. So here what we will get, x plus y plus z, x plus y plus z. I am multiplying by first row to first column. Multiply by second row to this column. What we will get, 0 plus y plus 3z means y plus 3z. Lastly, 0 minus 3y plus 0 means minus 3y. On this side 6, 11, minus 6, keep it as it is. Now we are able to apply equality of two matrices. So by equality of two matrices, see what we will get here. So here we can say that x plus y plus z is equal to 6, which is our equation first. Then y plus 3z is equals to 11. This is equation number second. And minus 3y is equal to minus 6, which implies that y is equal to minus 6 divided by minus 3 means 2. Y is equal to 2. In this way we have got the value of y. If we are substituting y is equal to 2 in equation number second, we are able to find out value of z. So put y is equals to 2 in equation second. We get, let us see, we are what value of z we are getting here after substituting this value of y in this equation. Y is equal to 2 plus 2 on this side will become minus 2, means 11 minus 2 is 9. So 3z is equals to 9 means z is equal to 3. So in this way we have got the value of z. Now substitute y is equals to 2 and z is equals to 3 in equation first. Let us see what we will get if we are substituting these values in equation number first. So x, keep it as it is, y I am replacing by 2 and z I am replacing by 3. On this side 6, keep it as it is, which implies that x will be equals to, here we will get 5 plus 5 on this side will become minus 5. So 6 minus 5 will be equal to 1. So x is equals to 1. So x is equal to 1, y is equal to 2 and z is equal to 3. In this way we have got required value of x, y, z, which are nothing but our required 3 numbers. So that's why we can conclude that, so required 3 numbers are 1, 2 and 3. In this way we have solved this example using matrices. Now see the example number 4th. In this example, observe the given condition. The cost of 4 pencil, 3 pens and 2 books is rupees 150. This is first condition. Second condition, the cost of 1 pencil, 2 pens and 3 book is rupees 125. And the third condition is the cost of 6 pencil, 2 pens and 3 book is rupees 175. Using this given condition, question is to find out the cost of each item by using matrices, isn't it? So we have to find out cost of each item. So let us denote the cost of each item be by rupees x, rupees y and rupees z. What is first item here? Pencil. So we are supposing that the cost of a pencil be rupees x, a pen be rupees y and a pen be rupees z. Now using the given condition, let us try to form the linear equation. Cost of a pencil is rupees x, then what is the cost of 4 pencil? Will be 4x. Cost of a pen is rupees y, then cost of 3 pens will be equal to 3y, and cost of a book is rupees z, so cost of 2 book will be equal to 2z, and this total bill will be equals to 150, means sum of cost of 4 pencil, 3 pens and 2 books will be equals to 150. This is the given condition. Now observe the second condition. 1 pencil, cost of 1 pencil is rupees x, 2 pens means 2y, and cost of 3 book it will be 3z, and this total bill will be equal to 125. The cost of 6 pencil means 6x plus cost of 2 pen is 2y and cost of 3 book will be 3z, and this total bill will be equal to 175. In this way we have got 3 equation using given condition in the example. Now we are solving this equation using reduction method. So first write down the given equation in matrix form. So here we can say that matrix form of equations is So whenever we are writing the given equation in matrix form, at that time in the first matrix we are collecting what coefficient? What is the coefficient here? 4, 3, 2. In the second equation 1, 2, 3. In the third equation 6, 2, 3. In the second matrix we are collecting variable where variables are x, y, z, and on the right hand side we are collecting the constant term, that is 150, 125 and 175. In this way we have got the matrix equation. Now second part is to convert this first matrix into upper triangular matrix. Since we are applying reduction method is easy comparatively to inversion method. That's why here we are applying reduction method. So using reduction method, using row transformation, first we have to convert these three elements into 0 as we are applying what? Reduction method. To convert this element into 0, our operation is on R2 as is stand 1 is there. If I am multiplying to 1 by what? 4. So 1 into 4 is 4 and 4 minus 4 will become what? 0. That's why we are subtracting R1 from it. Later on our next operation is on R3. Element of R3 is 6 and from 6 we have to subtract 6, and that's why I'm using corresponding element of R2 and I'm multiplying to R2 by 6 and we are taking subtraction. If I'm multiplying here by 6 we will get 6 and 6 minus 6 will become 0. Let us perform these two operations. Our operations are on the element of R2 and element of R3. So on both sides keep the element of R1 as it is. So what is the element of R1? On left hand side will be 4, 3, 2 and on the right hand side will be 150. Now we are performing this operation on the element of R2. We are multiplying to R2 by 4 and we are subtracting R1 from it. So multiply by 4, 1 into 4 is 4, 4 minus 4 will be equal to 0. Then multiply by 4, 4 to the 8, 8 minus 3 will be equal to 5. Again multiply by 4, here we will get 12, 12 minus 2 will be equals to 10. Multiply by 4, here we'll get 500, 500 minus 150 will be equal to 350. In this way, we have performed first operation on both the side. Now perform second operation. Our second operation is on element of R3 and here we are using corresponding element of R2 and we are multiplying to R2 by what? Minus 6. So multiply to R2 by minus 6. Minus 6 into 1 is minus 6. Minus 6 plus 6 will become 0. Again multiply here by minus 6. Here we'll get minus 12. Minus 12 plus 2 will be equals to minus 10. Again multiply by minus 6. Minus 6 into 3 is minus 18. Minus 18 plus 3 will be minus 15. On this side also we are performing the same operation. Multiply here by minus 6. So here we will get minus 750. Minus 750 plus 175 will be equals to, here we will get 5. Then 15 minus 8 will be 7. Carry 1. And here 7 minus 2. 7 minus 2 will be 5. So minus 575. Minus 575. In this way, we have converted these two elements into 0. Lastly, we are trying to convert this element into 0 so that this matrix will become upper triangular. To convert this element into 0, our operation is on R3. So better we use the corresponding element of R2. We are multiplying to R2 by 2. So we will get 10 and 10 minus 10 will become 0 if we are taking addition. So that's why we are taking addition here to convert this element into 0. So let us perform this operation on the element of R3. Since operation is on element of R3, so on both sides keep the element of R1 and R2 as it is. So keep the element of R2 also as it is. Even you can observe that all the element of R2 are divisible by 5. So that's why I'm simply dividing both sides by 5 so that our calculation part will become easy. So if I'm dividing by 5, here we'll get 1, here we'll get 2 and here we will get 70. Now perform this operation on the element of R3. We are using corresponding element of R2 and we are multiplying to R2 by 2. So here we will get 0. Here also we will get 0 because this operation specially we have performed to convert this element into 0. Later on, observe in remaining cases what we will get after performing this operation. Multiply to R2 by 2. So 2 into 10 will be 20. 20 minus 15 will be 5. Multiply by 2. Here we will get 700 minus 575 will be equals to plus 125. 700 minus 575 will be equals to 125. Now this matrix becomes upper triangular matrix. That's why we are taking multiplication of these two matrices. This will be the next step. So here take the multiplication of these two matrices. Let us see what we'll get. Whenever we are taking multiplication, we are multiplying by row to the column. So what we'll get here? 4x plus 3y plus 2z. 4x plus 3y plus 2z. Multiply by second row to this column. 0 plus y plus 2z means y plus 2z. 0 plus 0 plus 5z will be equals to 5z. On this side 150, 70 and 125, keep it as it is. Now here we can observe that these two matrices are equal. That's why we are applying definition of equality of two matrices. So by equality of two matrices, let us see what we'll get. So here we will get 4x plus 3y plus 2z will be equals to 150. Let us denote it by equation number first. Y plus 2z, its corresponding element on this side is 70, denoted by equation number 2. And lastly 5z is equal to 125. Implies that z is equals to 5 will get divided on this side. 125 divided by 5 will be equal to 25. In this way we have got the value of z. Now if we are substituting this value of z in equation number 2, let us see what we'll get. Put z is equal to 25 in equation 2 we get. So observe what result we are getting. If we are replacing z by 25, 25 2s are 50, plus 50 on this side will become minus 50, and 70 minus 50 will be equals to 20. So y will be equal to 20. Now substitute this value of y and z in equation number first, see what we'll get. So we are substituting y is equals to, what is the value of y here? 20 is equal to 20 and z is equals to 25 in equation first. So equation first will become 4x plus 3y, but y is equal to 20, plus 2z, z is equal to 25. On the right hand side keep 150 as it is. So therefore 4x will be equals to, here we will get 40 and here we will get 50. 40 plus 50 is 90 plus, sorry, here 60. 3 into 20 is what? 60. 60 plus 50 will be 110. 110 on this side will become minus 110. So 4x will be equals to 40, implies that x will be equals to 10. In this way we have got value of x also. So that's why we can say that cost of a pencil be rupees 10. Cost of a pen be rupees, y means what? Y is equal to 20, that is the cost of one pen. And cost of a book is rupees 25. So cost of a pencil is rupees 10, cost of a pen is rupees 20 and cost of a book is rupees 25. In this way we have got our required values. Now see the example number 5th. In this example, the given condition is that the sum of three number is 6. This is the first condition. So let us denote, and question is also find the three number by using matrices. So let us denote the required three numbers by x, y and z. And according to given condition, let us see what equations we are getting here. Our question is to find out what three numbers satisfies this condition. Let us denote these three number by x, y, z. So our first condition says that sum of these three number is equal to 6, means x plus y plus z is equal to 6, which is our equation number first, which you are getting from the first condition. Now second condition, thrice the third number. Thrice the third number we have denoted by z. When added to the first number, first number we have denoted by x, gives 7, which implies that this equation can be written as first write down x, then write down 3z is equal to 7. This will be our second condition. Now observe the third condition. On adding 3 times the first number, 3 times the first number is added to the sum of second and third. Sum of second and third means what? Second is y and third is z. 3 times the first number is added to sum of second and third. It gives 12, which is equal to 12 is our third equation. So using the condition in the example, we have got 3 equations. Now let us write down this equation in the matrix form. So we can say that matrix form of equation is, whenever we are writing given equation in matrix form, at that time in the first matrix we are collecting what? Coefficients of x, y, z. What is coefficient of x, y, z in first equation? 1, 1, 1. In the second equation 1, 0, 3. 1 because term of y is absent means its coefficient is 0 and coefficient of z is 3. And here we will get 3, 1, 1. Here write down the variable x, y, z and on this side collect the constant term which is 6, 7 and here we are getting 12. As we have seen that reduction method is easy comparatively to what? Inversion method. So let us try to solve this equation applying reduction method. And in case of reduction method, first aim is to convert this matrix into upper triangular matrix. So here these 3 elements we have to convert it into 0. So to convert this element into 0, our operation is on R2. 1 minus 1 means R2 minus R1 will convert this element into 0. Next operation is on the element of on this element which is the element of R3. What is the element of R3? 3. From 3 we have to subtract 3. So 3 minus 3 R1. So if I am multiplying here by 3, 3 into 1 is 3 and 3 minus 3 will become 0. Let us perform these 2 operations on the element of R2 and R3. So our operation is on the element of R2 and R3. So on both sides keep the element of R1 as it is. Element of first row means R1 on left hand side is 1, 1, 1 and on this side is 6. Now we are performing first operation on R2. So what is our operation on R2? R2 minus R1 means 1 minus 1 will be equal to 0. Then 0 minus 1 will be equal to minus 1. And here 3 minus 1 will be equals to 2. And on this side 7 minus 6 will be equals to 1. Now let us perform the next operation on element of R3. Here also we are using corresponding element of R1 and we are multiplying to R1 by minus 3. 1 into minus 3 is minus 3. Minus 3 plus 3 is 0. Again 1 into minus 3 is minus 3. Minus 3 plus 1 is minus 2. Again 1 into minus 3 is minus 3. Minus 3 plus 1 is minus 2. On this side also 6 into minus 3 is minus 18. Minus 18 plus 12 will be minus 6. Lastly, let us try to convert this element into 0. So our operation is on R3. What is the element of R3 here? Minus 2. And we have to add plus 2 into it. So get plus 2 here, we are multiplying by minus 2 to R2. Minus 2 into minus 1 is plus 2. Plus 2 minus 2 will become 0. So let us perform this operation on the element of what? R2. So keep the element of R1 on both sides as it is, that is 1, 1, 1. Here keep a variable as it is. On this side element of R1 is 6. So here keep the element of R2, that is 0, minus 1, 2 as it is. On this side 1 also as it is. So perform this operation on the element of R3. We are using corresponding element of R2 and we are multiplying to R2 by minus 2. Here 0, this operation specially we have performed to convert this element into 0. Minus 2 into 2, minus 4, minus 4, minus 2 is minus 6. Minus 2 into 1 is minus 2. Minus 2 minus 6 is minus 8. Since this matrix becomes upper triangular, so now we are taking multiplication of these 2 matrices, which is nothing but next step in case of reduction method. So on this side keep this matrix whose elements are 6, 1, minus 8 as it is. So on the left hand side we are taking multiplication of these 2 matrices, multiply by first row to first column, x plus y plus z. So here we'll get x plus y plus z. Just simply I am multiplying by first row to first column. Now multiply by first row to this column. What we will get? 0 minus y plus 2z, minus y plus 2z. Then 0 plus 0 into plus minus 6z is minus 6z. So these two matrices are equal. That's why we are applying definition of equality of two matrices. So by equality of two matrices, let us see what we will get here. So comparing first element here, we can say that x plus y plus z is equal to 6, denoted by equation number first, minus y plus 2z will be equals to 1, minus 6z will be equal to minus 8, denoted by equation number 2. This implies that z is equal to minus 8 divided by minus 6. Minus minus will get cancelled and 8 upon 6 will be equals to 4 by 3. In this way, we have got first required value z. Now substituting this value of z in this equation, we are able to find out value of y. Now put z is equals to 4 by 3. So put z is equal to 4 by 3 in equation 2. Let us see what we'll get. Minus y, keep it as it is, plus 2 into z, where value of z is equal to 4 by 3. On this side, keep 1 as it is. So minus y on this side will become plus y. On this side, 2 into 4 is 8, 8 by 3, and plus 1 on this side will become minus 1, which implies that y is equals to. So 3 into 1 is 3, 8 minus 3 is 5, 5 by 3. In this way, we have got our second required value. Now substitute these two values in equation number first. So put y is equals to 5 by 3 and z is equals to 4 by 3 in equation first. Observe the equation first. X plus y, y is 5 by 3 and plus z is 4 by 3, and on the right hand side 6, keep it as it is. Just we have substituted the value of y and z in equation number first. Let us simplify it. X plus, here denominators are same, so take the addition of numerator. 5 plus 4 is 9, 9 by 3. On this side 6, keep it as it is. So x is equal to 9 by 3 means 3, and plus 3 on this side will become minus 3, so x will be equal to 3. In this way, we have got the first required value x, and that's why we can say that therefore required three numbers are what? 3. Then y is equals to what? 5 by 3, and z is equals to what? 4 by 3. In this way, we have got the required three numbers which satisfies all the condition in the given example. In this way, in this video, we have seen 3 word problem. Now only 3 word problem from this miscellaneous exercise is remaining. We will discuss last 3 example from this chapter, from this miscellaneous exercise in the next video. So if you think that these videos are helpful to you, like the videos and share these videos with your friends also.